All right, we're back at it for week 5. We got the word last week that we're not coming back at all, so saw that coming. It's just unfortunate. This is hard doing this. Much easier to be in the building. I'd rather see you guys. Not one to be like being stuck at home. But it is what it is. Enjoying some family time and all that, but seems like you guys are doing pretty well based on the surveys. Hope you guys are doing well. This week we're going to move on to sequences and series. We're going to start out with arithmetic sequences this week. I'll get to that more in a second. So let's just get at it. A sequence in general is just an ordered list of numbers. It's just a set of numbers. You have a finite sequence, you have an infinite sequence. Pretty self-explanatory between those two. Finite, there is an endpoint to it. Infinite, it goes on forever. The ... tells you that it goes on forever. So we'll see a little bit of both. In a sequence, you'll see some labels. It's made up of terms called a sub n, whatever it may be. So like in this sequence, we have 2, 4, 6, 8, and it goes all the way and it stops at n. Some random number it stops at. So we have a sub 1 is just your first term. That's all that means. A sub 2 is your second term, and so on. A sub n is just a general nth term. So we're just talking about any term in the sequence. So the whole point of sequences and series is to condense a sequence down into an equation, essentially, so we can find any term in the sequence. So there is a big use to this, and it's a use in calculus as well, hence the name pre-calculus. We're kind of getting ready, especially towards the end of the year here. We're using a lot of stuff that's going to get us ready for calculus. But we have that. Just some general information moving forward first. So we have two types of sequences, as I mentioned. We have arithmetic, which we're going to be talking about now. They have a common difference. I'll talk more about that on the next slide. We have geometric, which will be next week, which have a common ratio. But again, we're focusing on arithmetic. That's it. So arithmetic sequences, it says the difference of consecutive terms called the common difference must be constant. For example, in the series 1, 4, 7, 10, we're adding 3 to the previous term to get the next one. So 1 plus 3 is 4, 4 plus 3 is 7, 7 plus 3 is 10, and so on. The next term in that sequence would be 13 if you were to write it. And we would identify it as the common difference is 3. Common difference is going to be used with a variable called d. To find the common difference, you just take two random terms, two sequential terms, so two terms next to each other, and subtract them. So I do second term minus the first term. You always do the further along down the line, so third term minus the second, fourth term minus the third, fifth minus the fourth, and so on down the line. You need to double check yourself to make sure the common difference is constant. So you do need to do it a second, maybe third time if you want, just to double check. This is something that can easily be done in your head. I don't expect any work here. I'm going to show work on the pages, on the slides, just to show it. So we have an arithmetic rule or an explicit formula. It's referred to as both. I'm referring to both of them. I think the worksheet I refer to it as an explicit formula. It's the same thing. It's just a matter of what book you're using, what teacher you have, stuff like that. The general rule for an arithmetic sequence is a sub n equals a sub 1 plus n minus 1 times d. A sub n is whatever term you're talking about, just usually a general term. A sub 1 is the first term in the sequence. N is the term number. Notice they're both in blue. Those are going to be the same numbers there. D is the common difference. We're going to be using general information to find the explicit formula in different scenarios. That's it. So let's look at examples. First thing, very easy here. Tell whether the sequence is arithmetic or not. If it is, identify the common difference. For a sequence to be arithmetic, it needs to have a common difference. So we look at this. We have 2, 5, 8, 11, 14. Just start finding the common difference. 5 minus 2, second term minus the first, the difference is 3. Double check it. 8 minus 5 is 3 also. If you want, not necessary, you can triple check it. So if the common difference is consistent, it is yes, it is an arithmetic sequence. The common difference itself is 3. All right. Got a second example there for you. You can do that if you want. It's pretty self-explanatory there. Now, this one, number 3. Checking this sequence out, we have 8, 4, 2, 1, 1/2. It is a constant sequence. Doesn't mean it's arithmetic though. We take the first two. 4 minus 8 is -4. Difference can be negative, that's not a big deal. Then we double check it. We do 2 minus 4 is -2. They already don't match, so we don't need to go on and triple check. This is why you need to double check though. This is not a arithmetic sequence. There is no common difference. All right, and you can see the example in 2 as well if you want it. That's first part of this. Just some extra examples pulled out of a book. All right, we're going to write the explicit formula now. This is what we're focused on the rest of the way. You need A1, so the first term, and you need the common difference in order to write the explicit formula. So we have this. First term in the sequence, easy. 7. It's literally given to you. It's first term in the sequence. Common difference, these are going to be arithmetic, so you are going to have a common difference. Just find it. 11 minus 7 is 4. Make sure it's a positive 4 because you're doing 11 minus 7, not 7 minus 11. You're adding 4 to each term, so it's a positive 4. Think about that. You have what you need. You have 7, you have 4, you plug it in. 4n plus 3 is your explicit formula. To do that, you plug in A1 and D. So 7 is A1, 4 is D. I distribute the 4. I know it's at the back end, but we still distribute. So it's 4n minus 4 plus that 7. Combine like terms, write the variable first. That's it. Then I ask you to find A sub 30. So what that's really asking is find the 30th term in the sequence. You can just add 4 to these 30 times if you want, but the whole point of having this formula is to shorten that process up. All you do is plug in 30 into the formula you found. Alright, that's the whole point of that. It's just 123. This is stuff that can be done in your head. I don't necessarily need to see work this week. I'll explain more in the assignment what kind of answers I'm looking for or how I'm going to give you the ability to check yourself, but I don't necessarily need to see a lot of work in this. I have a lot of work in our notes. Here's a second example. I'm not going to go over it just because I only have 15 minutes of free stream time on this, so I'm going to keep it within that window, but it's the same exact problem, different scenario. I have a common difference of -3 this time. It's the only difference. Some extra examples there, again, pulled out of a book for you. Use it if you want, but I have some extra examples this week. Next scenario. We have our common difference, which we need, but we don't have the first term. We have some random term in the sequence, but I need the first term. So common difference is 4. Actually, let me just pull this one. I'm just going to pull all this stuff off. I'm going to jump to the next example, just so we have a negative common difference. That's all. Same thing as what I was talking about. We have our common difference, but we don't have our first term. So our common difference is -3. I need to find my first term. My first term ends up being 7. Well, how do we find that? We have A sub n, which is -35. We have our common difference, and we know n because it's 15. So we plug all our information in. -35 on the left side, A sub 1 plus 15 minus 1 times negative 3. I'm showing all the steps here. Do your orders of operation, subtract first, then multiply, you get a negative 42. Add 42 over a sub 1 equals 7. Alright, so that's how we got that. Then I do what I did in the last example that I talked through. Plug it in, you have a sub 1, you have d. Plug it in, find the explicit formula. It's negative 3n plus 10. The second part of this type is I ask for the first 3 terms in the sequence. First 3 terms are 7, 4, and 1. I had 7 already. I found that. There are 2 ways to find the rest. The easiest way is just use the common difference. I left that from the last problem. Subtract 3. So, in this 2 ways, the easiest way, just start with the first term that you found, subtract 3 to find the next 2. Easiest by far. Next one, you can actually use the formula. Plug your numbers in. First term, second term, third term is your n. That's it. Alright, so we got that. Extra example there. Now, last scenario, last example I'm going to walk through with you. You have 2 examples here. I'm just going to walk through one. We don't know our first term or our common difference. We have 2 random terms in the sequence. That's it. Now we're bringing systems of equations back. First, we write a system of equations like I mentioned. We kind of set each individual equation up just like we saw in the last problem. We use a sub 7 equals 58 for the first one. A sub 11 equals 94 for the second one. Simplify. We get 58 equals a sub 1 plus 6d. 94 equals a sub 1 plus 10d. Systems, we added them. This week we're just going to subtract them. I don't want to sit here and multiply it by a negative 1. Just subtract it. Just watch your signs. 58 minus 94 is negative 36. A1 minus A1, they cancel out. 6d minus 10d is negative 4d. Divide by negative 4, you have your common difference, which is 9. Take 9, plug it into either one of the equations right here typically. Doesn't matter which one, whatever you want. 6 times 9, we get 54. Subtract 54, we get a sub 1 equals 4. We have our common difference. We have our first term now. That's all I'm asking for. Finish it out just like we've been doing to find the explicit formula. There's all the work there. Alright, there's no second part to this. There's no finding a 30th term or first 3 terms of the sequence. Nothing like that in this one. Just the explicit formula. Alright. I have a second example here. It just has a negative common difference. That's the only difference. You can check that out. I have another example there as well. That's it. Something different to end out the year here. This is going to be our next few weeks. I got a worksheet as usual. Weekly survey as always. Easy 15 points hopefully for us this week. Just try not to fall behind. If you have questions, hit me up. At any point in time, I'll answer them, you know, whenever or however I need to. The answers this week, I'm going to post midweek. I'm going to give you just answers to select problems. And I'll give you all the work and reasons why for each of those as well. So I'll do that midweek some point. It'll probably be posted like Wednesday or something. But if you guys have questions, hit me up like I said, and have a good week. Alright guys, see ya.